A portion of today's video is brought to you by Surfshark. I'm in the process of building a new energy-efficient net zero modular home that's being built in a factory. Now, why did I choose this path versus one of the many other sustainable and energy-efficient methods like stick-built passive homes, ICF, earthships, fill in your favorite technique. Now, there's no one right way to do this, but I think the best way to walk through why I went the path I did is to show you how Unity Homes builds their houses. Now, this may spur ideas for yourself. I had a chance to see my house's wall panels getting built in the factory, and to say it was cool would be an understatement. After seeing this, you may see why factory building energy-efficient homes and buildings might be a good path for the future. And before getting into the factory tour, just a quick recap of what's happening here. In my previous home build video, I walked through the high-level overview of what I'm doing and why. In short, I'm trying to build an energy-efficient net zero home, which means a house that generates as much electricity as it uses over the course of a year. I'm a big fan of passive houses, but didn't want to go through all the logistical hurdles of getting actual passive house certification. That's when I zeroed in on factory-built modular homes that have proven that they can hit that level of performance with some additional benefits. And I'll get into those in a bit, but at a high level, here's how it works. In my case, I'm working with the company Unity Homes, which is an offshoot of the company Bensonwood Homes. In principle, the two companies share the same prefab, factory-built methodology, but Bensonwood is on the full custom design, high-end home side of the spectrum. They do everything from homes to office buildings. Now, Unity is the more affordable modular approach side of things, which uses the same sustainable and energy-efficient principles. In fact, both Bensonwood and Unity projects are built in their facility in Keene, New Hampshire. And before I go on, I hate that I have to state this, but to head off the overly skeptical folks in the crowd, I have no business relationship with Unity or Bensonwood, other than being a customer who paid full price for the home that they're building for me. And that said, it's a really cool company that's the brainchild of Ted Benson. Now, the way it works is that you select from one of 5 base models. From there, you can actually customize it a fair amount to dial it into what you want and need for your home. Now, the benefit of this approach is that it drives down costs.
Unity is really completely focused on making high performance, high quality buildings more affordable and more accessible. In the Unity constellation, we have developed 5 different platforms to kind of standardize enough about the building that we can bring costs down in the design process, in the construction process.
In our case, we went with the Xyla model and customized the design. It's kind of like Lego blocks, so you can flip things around, add an additional module, and dial things into what works for you. For my wife and I, we added a connector between the main house and the attached garage, which has my studio that's built off the back of it. Now, there's a whole bunch of reasons that I did that for my studio, which I'll get into in future videos, but I was very impressed with how much we were able to customize it within just the Xyla base plan. At this point is when the design transitions over to what they call the virtual fabrication, which is probably one of the most important aspects of Unity's system. It shouldn't be a surprise that all of the design is in CAD software, which is computer-assisted design. However, Unity's virtual fabrication process is a little more sophisticated.
One of the key elements is that we actually build a digital twin of the building in the virtual world. And in that digital twin, kind of everything is there. The infrastructure is there for the mechanical systems, the foundation is there, right down to trim and, other finish elements are in that virtual model.
Everything in this virtual model or digital twin is right down to every bolt. It takes the idea of measure twice, cut once to a whole other level. And here's what my model looks like.
This is the solid model. If I was to turn it into a wireframe model, you've got every piece. So you've got sleeves. Because this is an insulated panel, you now have sleeves that you need to add for wiring, to get wiring to the exterior for exterior lighting outlets.
Right.
We actually take the 3D model before it gets to this elaborated stage and cut sections at the critical areas. So we do a longitude and a latitude section cut to see what that looks like. We'll add them to the plans. We'll call out critical code requirements, certain amount of insulation in your attic, any floor changes that have to happen between, say, the garage and the main house.
Every aspect of the house is checked, rechecked, and checked again. Now, I've talked about digital twins in other videos, but it's pretty cool to see this applied to building a house. And once everything is approved, this virtual model is what's used for the factory build. Jay Leppel, who runs production at the Keene facility, walked me around the floor to see my house getting built. But before seeing the factory in action, I'd like to thank Surfshark for sponsoring this portion of today's video. Now, I always recommend using a VPN when using public Wi-Fi, but VPNs can be very useful even when you're at home. A lot of online services use some pretty sophisticated commercial tracking and machine learning to apply very targeted advertising, and a VPN can protect you from some of that. Surfshark's Clean Web does a great job blocking ads, trackers, and malicious websites, making it safer to use the internet even at home. And you can even make it look like your IP address is coming from a completely different country. This can come in handy if you want to stream a video that's only available from a specific location. And one of the best parts of Surfshark is that it's easy to set up on all of your devices, whether that's iPhone or Android, Mac or PC. Surfshark is the only VPN to offer one account to use with an unlimited number of devices. Use my code to get 85% off plus 3 extra months for free. Surfshark offers a 30-day money-back guarantee, so there's no risk to try it out for yourself. Link in the description below, and thanks to Surfshark and to all of you for supporting the channel. Now back to the factory floor with Jay.
Over here we can see your project actually, and what we do is we break up the panels into these simple 3D geometric shapes, and we break up the whole building. So we've got our exterior walls, our interior walls, all of our truss parts, sheathing, and all of our open exterior things, which are uninsulated. That could be ceilings, exterior roofs. It's always color coordinated as we are going to raise the building on site. So it says, here's our first bundle, our first panels. This is where we're going to start. And it also informs us on our trucking and how many trucks we need to get all the product to the site. So moving over here, we have all of our bulk inventory for the process here at Production App and on site. So you'll see all the bulk inventory, and once a day, a person goes around and grabs the supplies. We have about 20 satellite carts, we call them, out on the shop floor. And this allows us to just have just-in-time delivery and not overstock too much material or products, whether it be tapes, fasteners, anything that's going to the site or the different stations here. And as we move through here, you're gonna see some large engineered lumber. And a lot of this is used on your house, but this is a little different than going to the downtown lumber yard where we have 16-foot material being grabbed in your pickup truck. This is all 36-foot long stock. But the reason we use engineered material is because of our CNC equipment. It becomes way more accurate to control how the length of everything and to cut it, to drill it, all the CNC processes.
This was the first area that drove home the scale of production that they're working with. Since they know the exact amount of cut material needed for my project, there's very little waste. You're not having to buy extra wood just for my project to make sure you have enough that may get tossed at the end of the project. This wood spans multiple projects, which helps to reduce waste. It also means that they can buy at scale and save on costs. And this also ties right back to the virtual fabrication model that I showed earlier, which Jay showed me how that translates to the factory floor.
And what happens with those simple geometric shapes is there's an element routine or an algorithm that's run on this, and it automatically knows where the door arrows are going to be, the jacks, the king studs, our headers, depending on what type of wall component it is. So if I were to click here, this just gives me all the attributes. It tells me it's a 9.5-inch eye joist. It's got the production number, which they need for the shop drawings on the floor. It's a 2.5 by 9.5. That's 8 foot, 11 1/4 long. And so it gives us all these different attributes that are either color-coded for the machine or the job or the numbers. And then that results in a direct export to this machine behind me.
One of the benefits of using a CNC machine to produce parts like this is that it simplifies the assembly and can reduce the number of parts you need.
So if you could imagine this piece being a ledger up on the wall, mounted to the wall, and this be roof rafters for a screen porch or something like this. This takes out a lot of the guesswork. Nobody's running a tape measure. This is an engineered joint. They don't have to pull out the tape, mark the joint. It's already there. This goes into that piece, so it's like a puzzle. And you just put 3 stick nails in and it's done. And I don't have to then have procurement order joist hangers. We don't have to find the joist hangers, bring them to the correct spot, nail them all off. So there's a lot of intelligence built in, and our engineering is very involved with all that to get us some standard specs that we can always use.
This is when Jay walked me further down the line to see some of my wall panels getting produced, but along the way he took a second to walk me through what sets Unity's wall design apart.
When we get to passive house levels with totally thermal bridge free assemblies, I can show you a little something right here that can explain a little bit of the process up front. And if we could just take a look at this section, we've got a framing layer, which we're using I-joists on your wall. We've got our interior 7/16 OSB, which is our vapor control layer. And then we have a 2x3 stud that allows us to run all of our mechanicals in terms of wiring and things like that. And you'll see that a little better.
And there's a lot to unpack there, but in my wall panels, they're using 9-inch I-beam studs. Now this reduces the amount of material needed, but the I-beam also reduces the thermal bridging. Zip sheathing, which acts as a vapor barrier, is used on both sides of the I-beam with densely packed cellulose insulation in between. And we'll see that process in a bit. And then on the inside of the wall panel, they place 2x3 studs to give space for running electrical and plumbing and attaching the drywall.
And so what Matt's going to do is he's just going to start extruding this wall panel and putting the studs on there.
All of the material you see Matt using in this process is right there at hand's reach with rollers to help make it easy to pull onto the line. There are guides that help him to make sure that the alignment is right, and then the machine can saw and nail away on its own.
And so that's also a direct export from our CAD software to these machines. So there's no XY conversion or anything like that. It's right to the machine. He's asked what he did. So he just pumped up these air cylinders here to get that assembly. And he just pops them back down, pushes it in place. And it just both, if you didn't see that first time, it just keeps firing off those stick nails right there.
After this step, we followed the wall panel to the next station on the line, which is where they apply the zip sheathing. And not only does this act as the vapor barrier, but it also doubles as structure.
We do this on both sides to be resilient and have a robust product being done on site. Because if we see a small amount of weather, we don't want any leaching into our panels with rain or anything like that. What he's doing, he's tacking the last piece of sheathing. And then this machine is a giant bridge that runs over the top of this. And it will be nailing in its own pattern. It's a little wild how it nails.
Okay, so when Jay said that the machine that runs over the top was a little wild, he was right. But he also left out how loud it was. It's kind of like watching a gigantic, terrifying inkjet printer that shoots nails instead of ink. After that craziness, the machine moved on to routing out the windows, sconce boxes, and other cutouts.
This has been dragged up. It's all been taped off. Even the penetrations have been taped off just to make sure, again, that those blower door test numbers are going to work out. We know it's going to be foam later, so we're not worried about it. We just got to make sure that when we run the blower door test. So you can see these are 2x3s that are put in with a 5-inch nail. With the SC3, we're hogging out channels for the Romex. Yep. And so the electrician can just come in and fish wire rather than drilling every single stud through there.
I'm going to jump in again here because, as I've mentioned before about the passive house standard, one of the key elements is to reduce thermal bridging through the thermal envelope of the house. Now, a stud in your wall acts as a thermal bridge because it will transfer the heat through the wood, bypassing any insulation that you have between those studs. And the level of thought and engineering that's gone into the uni design to help account for thermal bridging was really driven home to me at this part of our tour, where Jay explained how the walls are attached to the foundation.
And I don't know if we can see it on this wall. Yeah, there's little holes on the bottom of here. We actually, when this is done, we put a PT piece of plywood that stitched this framing member and this framing member together.
Okay.
And then when we're at your job site with the foundation and we're snapping lines, these panels will fly in with the crane. So after layout, we can just go right to town with drilling this into the concrete through these holes at every 2 foot on center and drilling a tighten into the concrete. So we actually don't have J-bolts sticking out of the foundation where there's somewhere inside the envelope. They're actually all the way inside the envelope. So not dealing with any thermal conductivity in to out.
The level of thought that's gone into the placement of a bolt to help reduce thermal bridging. It's kind of incredible. Anyway, at this point, the wall is flipped from the interior side to the exterior side so that they can inject insulation into the wall panel.
This is an isocell machine that has 6 different ports in it, and it allows us to, we have preset recipes within this tablet right here, either on the Platen or right on that iPad right there, and it allows us to deal with different depths, different size cavities in length and width. When I say preset recipes, that's for getting the correct density, and he has a chart above the tablet there that tells us what the density requirements are for each square foot, or cubic foot. And so we actually take core samples, that's part of our checklist, and weigh them with that tube that he's got right there. And he weighs them to make sure he's within the density requirements for that size cavity.
Right.
And so we try to get, typical density is 3.5 per cubic foot. We try to get a little higher than that. We're putting these vertically. They're being driven over the road, kind of an agitator.
Yeah.
And so we try to make sure we go a little bit more dense so there's no settling that occurs.
Not settled. If you're curious what the insulation value, or R value, is when the wall is complete, it'll be about an R35. So after the insulation, it has more sheathing applied and nailed down, then taped to get an airtight and waterproof seal. After that's all complete, the wall is stood upright and then slid onto a track where the triple-paned European-style doors and windows are installed.
So these are tilt-turn mid-mount windows, and what we're able to do with these are some of your fixed windows, but we'll see some operable ones in a minute. But we're able to take these fixed units. You can see this suction cup machine right here, this lifter. This is a heavy lift window. This is triple glazed, 2 guys minimum, and they might get hurt. So we have this nice vacuum lifter, but we actually can pick this up and pre-tape all of the frame here. And then what it would look like then is this. We've got an easy opening window. You want to try out your window?
I do want to try out my window. I've got to try this out. This is pretty cool.
And we actually have a door install over here.
Oh, this is the living room wall.
See, you know it.
I know exactly where this is.
Yep. So again, we've got a tilt-turn window, but now we have a swing door here. That's ready to go. And this is a little different. This is hard in the panelized world. So we actually create what we call a door buck. And there's actually going to be a knockout in your foundation.
Am I weird for being super excited about those European-style triple glazed tilt-turn windows? Probably am. After all the panels are completed, they pack them up, wrap them, and set them aside for final delivery. As you can see from their process, they're applying building science to build more sustainable, energy-efficient homes in a more cost-effective way. In a general sense, when you can improve mass manufacturing on pretty much anything, you can drive the cost down to make it. It's no different when it comes to building a home like this or the latest smartphone. If you were building a home from scratch on site to the same specifications, it'd be more expensive to produce than using the methods Unity is doing inside a climate-controlled facility. You don't have to worry about weather impacting production, the materials you're using, or excess waste. However, as I mentioned near the beginning, one of the most important things that sets this whole process apart is virtual fabrication. And when I asked Ted Benson what was next for Unity, he mentioned this.
We're developing a software platform.
Oh, wow.
To make this automation that you're seeing in the actual production of panels and so on. We want to bring that into the software world so that when you produce a plan, it is ready for production. So that's been a big project of ours for quite a few years. And for the last 3 years, we've actually had a development team, on the project, and we're going to bring that a new company to market in the next year.
Is that software going to be available to other companies to take advantage of?
Yep. Yeah. It'll be open source, and we'll certainly be connected to the development of it. But one important aspect of it is that it will certainly be neutral and available to other companies like ours. Mm-hmm. Even the competitors, and to others in the marketplace, architects and builders and developers and supplier manufacturers as well.
Ted has been trying to push the building industry forward for decades now to build resilient, long-lasting, sustainable homes. The fact that they'll be open sourcing this software for anyone to use shows that commitment. After seeing this in person, my main thought was, why are we not doing this everywhere? There's still a lot more to come for my net zero home build, including everything from drilling my geothermal well, the on-site assembly and finishing of everything from the factory, solar and battery storage. So stay tuned, because there's a lot more to come. And so what do you think? Do you think systems like this are the way to go for construction? Jump into my comments and let me know. And be sure to check out my follow-up podcast, Still to be Determined. We'll be discussing some of your feedback. And if you like this video, be sure to check out one of the ones I have over here. And a huge thank you to Ted, Jay, and the rest of the Unity team for inviting me in to see my house getting built. Every single person I had a chance to meet was amazing. was an incredible experience. And thanks to all of you for watching. We'll see you in the next one.